Hey, folks.
Hello.
Olá.
Hola.
Aí.
Thanks everyone for joining. We'll give it another minute or so. Let some other folks join. All right. So welcome to Tag Runtime meeting. We do have two items on the agenda today. The Podman Container Tools presentation as well as Hyperlight. So since there's two, and please ask each group to be about 25 minutes for yourself. We can split it in half that way. So I guess Podman Container Tools is up first. Who is presenting from that team?
I think I'm doing most of the talking.
Cool.
Maybe someone like Mark, could you present for me and then the demo screens don't get all mixed up?
Cool. Nice to meet you, Brent.
Or,
Mark.
yeah, I guess I can try. Hold on a second here.
I can do the screen share if you want. Up to you.
Well, sounds good. Let's do that. And I'll just cue you to move forward.
All right, let me know if this is good. You know what, Brent? Actually, can you do the share?
I will try.
Unless there is. Oh, hang on. As long I can do it. I was having a problem with full screen.
Nice.
So let's see. All right. So we can start there.
Okay. Welcome, everyone. And thank you for your time. My name is Brent Bowdy. I'm currently the Podman architect. And we're here to just give a quick run through on Podman. I assume some familiarity here, so we'll try to hustle through in the interest of time. But Podman is this is sort of our motto. It's a daemonless open source secure application to run OCI containers, manage OCI containers, build OCI containers, and all that good stuff. We are, and always have been, open source. We spawned out of a project that's drawn out of a project that is also in the CNCF in Cryo. We are secure in the sense that we have very tight integration in things like SC Linux, rootless technologies that limit capabilities, not only in what you can do on a system, but privileges along the way. And we were initially supported only on Linux, and the containers in question that we run are Linux containers, so we're sort of a native tool to that. Okay, Mark.
Okay. Did you want?
How much of the history do you guys want to hear? Do you want us to start from the invention of time, or should we just kind of hit what's gone on recently?
I would say it's up to you guys.
Okay.
If you want to talk more about kind of the progress towards Sandbox, if that makes sense, or
Yeah.
whatever whatever you want to hit on.
Yeah, I mean, I'll just sort of briefly say here, we did start in 2017, and we took a little bit of ramp up time, but you can see we've had pretty consistent releases on a pretty consistent basis, leading up to 2022, where with Podman version 4. Mark, you want to bump to the next one? And then the latest major release that we've done was in the beginning of 2024. I think it was 1Q, where we released Podman 5.0, which was largely a rewrite of our Mac and Windows function, as well as being able to do some breaking changes that we needed to do in Podman in general to be able to move things forward. No one likes to introduce those changes, but we do them at major releases. And then tail end of 2024 is when our relationship with CNCF began, accepted into the sandbox in 2025. And we're going to continue to do the things that we do in an open and transparent manner, but also work on our progress towards the next CNCF step. Okay, Mark. Real briefly, we've had 700 some contributors over the 8 years of time here, 216 releases, 14,000 PRs, and we've actually get a ton of stars on GitHub, and that is still trending upward pretty quickly. Okay, just a brief overview of what's under the covers a little bit. Podman's made up of a CLI. The CLI, as many know, is modeled after Docker, but we certainly have our nuances. Connected to the CI, I guess, is something we call libpod, which is the library that drives all the management of the containers. It's where a lot of our code lives, strictly speaking, for Podman. We have a series of networking components so that the containers can get on the network. Some of the things involved there are things like Netavark and Aardvark, which are Rust-based tools that we've developed. Pasta, which is done by another open source party. It's a rootless networking technology, and then there's a flavor of IP tables and firewalling going on there to be able to do the port exposure and things like that. Next, Mark. We follow OCI closely. We don't have a lot of our own special sauce in the core of what we do. Follow the OCI spec, and that's that. We have a container runtime that whoop.
Sorry there.
We have a container runtime that takes the OCI spec and kind of makes everything start to happen. We have another small utility called Conmon, which is nothing more than a container monitor. It runs as Podman exit. It runs and manages the logging, and then the ability for Podman to be able to exec back into the container and do things like that, as well as passing on the exit codes for the container should the container naturally or abnormally end itself. A couple other big components here are a series of libraries, if you will, that power big parts of Podman and other container-related, actually all of our container-related tools. We've got container storage, which manage just what you'd think, the storage of containers and images in the various layers. We've got containers image, which is a low low-level image library, and it, among a ton of other things, manages the pushing and pulling between container registries. And then Containers Common, which is a sort of a just really what you might think. It's a common repo for largely for the management of how our tools work. So if you were to set an option in a configuration file, Common manages that file, tells us that it was set or not set, and that's the kind of library Containers Common is. It also has some networking and other related things in it. And then we have a database. Podman uses currently it's defaulting to SQLite. We used to default to BoltDB, and yet we still somewhat support that. But BoltDB has a terminal problem in it that we started to see in customer cases and decided we needed to make a move to SQLite for some reliability and potential performance benefits. We have two sister or brother or however you like projects in Builda, which is a utility and a library for us to do container image builds. That would be like your classic Docker build. It also can do some very advanced things. Not everything in Builda is in Podman, which is why it exists, a very handy tool. And then Scopio, which is a kind of like our Swiss Army knife, and it's a CLI utility that allows you to do inspection of images remotely, inspection of things locally, transforming things from one format to another. It's quite a handy and popular tool. Okay. A Podman machine is where a lot of our change has been in the last few years. This is how we refer to our Mac and Windows support. The equivalent would be, to some degree, the equivalent would be Docker desktop. Podman machine in itself is all still CLI based. The desktop portion of that is actually provided by Podman Desktop. It's a basically a virtual machine layer that allows Podman to launch a Linux VM so it can run Linux containers. Uses a custom Fedora CoreOS that we build and release. It's really intended to not be interacted with other than with Podman, but people do. And again, our motto: no cost, no sign up, no registration, no telemetry. You just use it. One exception with the CoreOS is WSL, which does not actually run CoreOS yet. We use a very small custom Fedora image there. Machine is supported.
Anything you want to add there?
What?
Yeah.
Oh, I was going to say, machine
No,
is
no, go
supported the
ahead.
best we can on Macs, on Windows, certainly on Linux. On Windows, we support Hyper-V and WSL. On Mac, we support two Vert technologies. One we call Apple HV, which is basically an integration with the API that Apple does expose, and then libkrun, which is something also built out of Red Hat and has the unique characteristic of being able to share the GPU from the Mac into the virtual machine so containers can use it.
I just had a quick
Yes,
question, if
please.
you don't mind. There's also a Podman desktop, right, which is a separate
Correct.
project.
It is a separate project, yes. And it's the CLI over the top of us, but it also has a ton of other things it does.
Okay, so that would be using Podman machine internally?
Correct. It's calling Podman, Podman's calling machine, and so forth.
Cool. Okay, thank you.
Yep. My pleasure. just in machine very quickly, the whole intent is to make it easy. It's literally Podman machine init, and you should be up and running within, not counting the download, probably within 15 to 20 seconds. And you can begin to start running Podman commands and working with containers. We do volume mounting from the host. We export the sockets out of the virtual machine so that other applications can directly link into a service level REST API that Podman supports, that supports both Docker calls and our API as well. And we certainly do the port mapping and expected behaviors there. Briefly about our community and how we interact with them. One more, Mark. We've always been, I think for quite some time, been doing a series of external meetings with the community. We have just what we call a monthly meeting where we present to the community things that we're up to. We also love and have had community members come in and talk about how they've used Podman, or projects they've built around Podman, or even some changes that they made to Podman. We have a community cabal where we try to talk about more public issues where we want community input and get a chance to sort of solicit input from those that do show up. And then we have mailing lists, among other things. Yeah, just briefly, I won't go through these, but these are the forms in which we do interact with community and other projects. Okay, so I think that's the end of the prepared material. We have a very short kind of micro demo to just, we assumed everyone knew like Docker, so then you know what we can do. So we just picked a function that we thought was kind of interesting that maybe crosses into the CNCF world a little bit better. And we can demo that if folks like.
Sounds great.
That's good.
Okay. Before I try to get the screen up, what we're going to show is something that's been around actually for a number of years, and it's quite popular by those that know about it. And it's when I say that, it's because Docker doesn't do this, so a lot of people don't know about it. We, a few years ago, put the ability to be able to ingest or output Kubernetes YAML based on containers running locally. The idea being that you could take, you could generate this YAML, you could work on how you want it to look by actually just running the container the way you want it, and then capturing that into Kubernetes YAML. And then you could either deploy that on an actual deployment, or you could share it, say, with a buddy and say, hey, if you run this YAML, it'll run exactly the way it's running on my machine, and you'll have that. Daniel, yes, we're aware of that. So I have a very quick sort of micro demo to show you folks how that works. So let me see here. This is a little bit different. Okay, everything's sort of vaporized for me, but I assume you can see this.
Yep.
Okay, and is the text size okay for everyone?
Yeah, it looks good.
Okay, so this is the command I was talking about. It's called podman kube. Has 4 subverbs: apply, down, generate, play. I'll just sort of demonstrate 2 of them. And I'm going to show you just sort of how what I like to do demos. I like to show that I don't have something up my sleeve. So I am going to show you this. I have a directory called hello, which I'll get into later. And then I have a simple script that just does some cleanup and preparation, a simple remove of everything. And then I'm going to very quickly build an image and then run it. So there's nothing really exciting or new. This is pretty typical, flow for users, but nothing really exciting or new going on there. But if we look, you can look at using the podman images command that we pulled an image from Docker there, from Docker's registry, and I made an image called hello. And if we also look, I can see that there's a container running, that this hello container, and you can see it's an nginx command, and that we have some port mapping going on. So if we curl that container on that 88 port, we get this beautiful banner that everyone loves. But where things get interesting is if I do something like this, where you see that the container running is called hello podman. If I do a pod kube generate hello podman, we get Kubernetes YAML coming out. And if I pipe that to something like a file like this and show you, it looks there the same. If I'm now going to remove everything that's running. And so we're sort of like sitting with a fresh system again here. Now, if we look at this hello and the directory add it, what we see here is there's a banner file, which is what you saw come out, a container file that describes how to build the container. And then we've got this YAML file sitting in this directory. So if we do a podman kube play now and feed it this hello YAML, you see a lot of the same stuff going on. We pulled the image, we built it, and then you can see we ran it. When we look at podman images, we see the same thing. Podman, yes, we see, oh, there's two containers. And the reason is Kubernetes based on pods, which is where podman shows some of its strength. Here we show the podman pod command, which is again different than Docker, and we see that there's actually a pod running that consists of two containers, which we saw above. And if we curl that, we get our banner. So we think this is kind of a unique and interesting approach that podman's taken. Those that use it have become very happy with it. We hear about being able to develop locally and deploy and getting the expected results and a lot less time doing the deploy iteration. I think that's the end of the demo that was prepared. I would be happy to answer any questions or show anything else that folks are interested in.
Would you see this as like an alternative to local development in place of kind, for example?
Where it really probably intersects a lot with is Compose, Docker Compose, which we also support. You'll see there, we actually have the verb compose there. And we'll actually, if you have Docker Compose present on your system, we'll actually honor that and take the file in and use it just like Docker does. Did I answer your question?
Yes, I think so.
Okay.
Any other questions from the group?
So you got accepted to Sandbox. What is the plan for incubation? And do you have any ideas, or you like to get to some number of users or growth, or you don't have any plans yet?
Mark, would you like to answer that?
Yeah, sure. So, You know, Podman, as you can tell, is it's a fairly mature and established project. So we do think that we're going to start working on the application right away, and we've started looking at what tasks, and a lot of that. The focus there is to figure out governance of some of the technical matters. I suppose first, really, we have to finish onboarding. But like I said, we're looking at the incubation task list and starting to, build a task list and spreadsheet so that we can follow through on that.
That makes sense. So the whole project is under one GitHub organization, right? Because there's like multiple utilities, right? So,
Correct.
okay, so that should work fine. Okay, great. Good to see. I mean, it's been around for a while, so I was just kind of surprised that it was just accepted into Sandbox, but it's great to see.
Yeah, I guess just for context for everyone, the sandbox was accepted just a month ago or so in the most recent review. There's a number of onboarding stuff to go through, so sandbox at least probably gives you a little bit of time to work out kind of the logistics of things before jumping straight into incubation, probably as well.
Yeah, and I think of it as less jumping into it, but like there's a lot more requirements in the application, so it's just
Sure.
there's no a lot of that. We may as well get started.
For sure. Cool. Any other last questions? Very good. All right. Thank you, Brent and Mark. Thank you so much for your presentation and demo.
Thanks a lot.
All right. Moving on next to Hyperlight. I think David is going to be presenting, right?
Thanks so much, dude.
I do.
Yeah.
Go
Hey,
ahead.
how's it going, everybody? So it's not going to be quite as polished as Brent and Mark. I didn't bring slides. However, I will talk to you a little bit about Hyperlight, and would you mind if I possibly share my screen?
Yeah, so Brent's screen is on. Brent, do you mind on sharing?
Brent just told me his Zoom crashed. Oh, there.
Oh no, there it goes.
Okay.
Oh, bummer. All right, cool. I will kick it off then. Let me know if everybody can see and if it's an appropriate size. If I see some thumbs up, I will proceed. We good? All right,
there.
looks good. Excellent. Thank you so much, everybody. Okay, cool. All right. So what is Hyperlight? So Hyperlight has been proposed as a sandbox project. It is relatively nascent open source project that has actually a longer history inside of Microsoft. So we started building this about 2.5 years ago or so. And we wanted to open it up for the world to use because we think it's actually useful. And I hope after I tell you about it, you will also agree. So Hyperlight is a lightweight virtual machine manager designed to be embedded within applications. It enables safe execution of untrusted code within micro virtual machines with very low latency and minimal overhead. So that's a mouthful. Let me unpack that a little bit. So first, virtual machine is kind of a misnomer here. We are using virtualization. We use KVM or dev MSHP to virtualize, create a secure sandbox for execution code. The idea that it's a virtual machine is more simply because we use these devices, these virtualization devices, to create these secure sandboxes. And usually, what we do is we put an OS in there. We boot up a kernel and run an operating system. However, in Hyperlight, That's not what we do. And this is where it starts to differentiate between Hyperlight and things like say Firecracker or other virtualization technology where you are actually running an OS. Hyperlight doesn't have really a kernel. You don't have any syscalls. You have like nothing initially. It is just simply like basically like malloc and um a very, 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 very simple you know, minimal kernel like malloc and virtual page tables. And then on top of it, you can put whatever you want on top, and then execute it within that secure sandbox. So um, imagine we basically cut out a chunk of memory and we say, okay, hypervisor, you're going to manage that, and we're going to get a vCPU, a virtual CPU. We're going to load up your application code on top of maybe some memory allocation or something like that. And then we're going to set up registers within the the virtual machine, and we're going to set the instruction pointer to the point where we want to start, and we're going to execute. This is very different than, say, running your boot init and then dropping into, your OS. It is single threaded at this time. The there there are no, like I said, there's no syscalls. Uh, but what we do provide is the ability to define your own interface that your guest application could then talk to your host. And you could then expose functions to these guests. This allows you to be very specific about the interface that you are going to provide, the kind of holes that you would want to punch in your security boundary. And we think this is actually a really useful case, so that you can build that security boundary, poke just the holes with strong types between them so that they can communicate, so that you can only do the work that you want within that guest and give the host just enough, or give the guest just enough access to the host to be able to do just the work that you need to do. So, where is this really, really useful? So you can imagine, how many times have you wanted to take user code and go run it in your application? Like maybe some little like user-defined function or something like that. Um, we get this a lot. Maybe some middleware or something like that that you want to inject into your service and put it into like the hot path for your service. Um, we get this a lot. We want to run this stuff really, really fast. As a cloud provider, we have a uh, the cost of goods is directly proportional to how much money we make at the end. So if we can deliver stuff for cheaper and faster for you, then we're happier, you're happier, everybody's happier. So what we can do with this is we can start up these tiny functions and create these secure sandboxes in about a millisecond or so. And for folks who may have seen it at KubeCon, this was actually demoed there. And the link is in chat for everybody. So if you want to, I won't try to run video on Zoom because I don't know if the audio is going to come through, but please feel free to watch it. So Rita Zhang, my manager, gets up there and talks about Hyperlight and runs a demo there. The code for that demo is here. And Danilo Ciaglione is the engineer that wrote that, and he's actually here with us today. What you'll see, it's about 1 minute. It's about as it's it's basically as lightweight as Hyperlight. So in that video, Rita goes through, and Rita starts hitting a cold endpoint, an HTTP endpoint that's serving back, executing a function inside of Hyperlight. So per request, creating a wholly new virtual machine, and then running code within that virtual machine, and then responding from that. And this is that's roughly like about a millisecond or something like that. And then if you actually take advantage of the sandbox for use, there will keep like a pre-initted version of that function. You're looking at probably, I don't know, 100 microseconds or something like that. It's very, very, very fast. So you can use this technology to give you request by request isolation for executing possibly hostile multi-tenant code. And you can do this with your own application stack. And I'll explain that in a little bit. Before I dig into that too much, are there any initial questions?
Sounds like none. But if anybody, David, I wanted to volunteer to show that demo that Rita had as well. You've got the link. If you want to see it, we can see it.
I guess I have a quick question. This is not then like you can run this in VMs as well, right? This is not like nested virtualization in any way, or is it?
That's an excellent question, Stephen. So you can use nested virtualization, or you can run it like if you're running it within a virtual machine, you're probably presenting to that virtual machine a like dev KVM, which is nested, right? So if you're in a virtual machine and you write an application that uses Hyperlight to start to create small virtualized sandboxes, it's going to use the dev KVM that's presented into that virtual machine that you're running within. So in that case, that may be nested virtualization. If you're running in a bare metal machine and the hypervisor is exposed at that bare metal machine, then you're probably at level 1 virtualization.
Okay, so if you were like in a cloud provider trying this out, you would require nested virtualization to be enabled in that VM in order to work.
That is correct, yes.
Gotcha. Okay, cool. Thanks.
Yeah, absolutely. Great question. Anyone else? Come on, I've said some weird stuff. There's got to be some questions.
Now, does everybody I'll jump in and sort of provoke the question, because one of the things that's hard to grok is that there's no operating system inside. So there is no distro. And that means, and there's no kernel boot, there's none of that stuff that you would regularly have. And Firecracker, for example, to take one example, there's several, is a great solution, a great engineering solution if you're going to host an entire OS. But in this case, because we do so much less work, we can create new VMs depending on the workload. You can create new hardware protected memory partitions or virtualized process if you want. I see Taylor's got his hand up, but I'll just finish and then Taylor. But you can create them somewhere between, depending on the workload, between 600 microseconds and a couple of milliseconds, and the other thing that's very useful is because there's no other workload inside other than the arguments and the actual process that you want to run, right? The binary or tool, whatever it might be. That means that the size of the VM can be extremely small, and by default, it's less than 1 megabyte. So you can create tons of these things with a footprint that doesn't really consume much memory. So that's kind of odd, and I sort of wanted to just emphasize that. Taylor, you had your hand up.
Yeah, I just wanted to ask a question. This is totally not a plant, but also this is me doing my due diligence as coming in as like a co-chair of the WASM working group. I know there's been talk when I've chatted with the various developers and I pretty much know all of you working on this project about using these things and for WASM as a possibility. It's obviously not restricted just to that, to be very clear to anyone where this is new to them. But what are kind of the plans for using this in WASM related projects, and what are the benefits it brings, and maybe what are some of the downsides? I just want to make sure we capture that in this recording as well, so we have that documented for later.
David?
Awesome. Thank you so much, Taylor. I couldn't have teed that up better. So Taylor alludes to the idea that running WebAssembly within here is where we're heading, and that is going to be a little bit more evident if you start to look at the Hyperlight roadmap, or just kind of like big chunks. We're very nascent, so we're still filling in a lot of the project roadmap and helping folks to understand where we're at. We just started having public calls, public community calls, which are fortnightly, and you can find that information on the root repository there. But to get to Taylor's question, the idea of WebAssembly is a really interesting runtime, or really interesting case for us. We started off running JavaScript and building native JavaScript runtimes into Hyperlight, and that was good for us. We were able to execute functions relatively quickly. The post the OS level kind of constructs that we needed, we could minimize, and then delve them, divvy them out like as we needed to from host guest interaction. But we look at Hyperlight as a really great target for executing WebAssembly and having a strong bounds around executing WebAssembly within the virtual machine. So the WebAssembly sandbox itself is considered secure. However, when you start to take a look at WebAssembly and WebAssembly runtimes, you're actually giving the WebAssembly components or modules access to exit that sandbox and to execute code that could be dangerous. So, for example, WebAssembly doesn't natively have file system access. However, there is a specification called WASI, the WebAssembly Systems Interface, which gives you access to do things like that, to access the file system. And you could imagine if there was a implementer of that runtime that perhaps had a bug in the way that it resolved relative files or something like that, you could easily find an escape there, or be able to read things that you don't have the privilege to read. We believe that uh, we can lock down uh, processes that would possibly have had more privilege than we would want to, but we can ensure that they don't. And we can do that securely. We can also make sure that we're cordoning off memory and making sure that we are following uh, our most stringent guidelines for security. So inside of Microsoft, we can't just run processes within jails. We do run everything within the hypervisor to isolate from one tenant from another. And our hypervisor choice is Hyper-V. However, because we do want this to be community appropriate, we target Hyper-V and KVM. And we are totally interested in targeting hypervisor framework on OS X. We have an issue out there right now to do it. However, it is, there are some constraints. The Apple hypervisor framework only allows for a single hypervisor per process. So we'll probably have to change the process model around a little bit for that. For KVM or for MSHV, we are able to, MSHV is a Microsoft hypervisor device that's exposed on Linux. So Hyper-V exposed into Linux. Sorry for abbreviating. What we do see there is that in both of those implementations, we're able to have multiple virtual machines, many thousands of virtual machines per process. So that's helpful. Did that answer the question?
Yes, I think it did. I do think, I mean, all the Daniels concluded that we must have a demo, so we're gonna have to do that. But I think that just for in terms of follow-up, I think it'd be really good in WASM working group, especially if when you're starting the Hyperlight or WasmTime guest for Hyperlight. I think it'd be good to talk about some of the rabbit holes that'd be interesting to go down in and the discussion items there that I don't think fit in this meeting. But I think great, that's a perfect answer to the question. So I do think we should schedule that in a follow up in a couple weeks or whenever you are all ready to do that. So
I would love it. I'm also super excited to like we're working on something that's kind of corollary to WebAssembly. Or actually just using some bits that are available in the WebAssembly ecosystem in a slightly different way. So one of the things that we've been working on is making it easier. So right now you can describe like guest and host functions and you can expose them, but it's really you're giving a string name for a symbol and you're saying describing the args and all that stuff for that function interface, and then both sides have to actually agree on it, and there's a lot of room for failure. WebAssembly has this idea of WIT, WebAssembly interface types, which is an IDL for describing interfaces between WebAssembly components. I don't have a link readily available. If somebody wants to drop it in chat, please do. It's really great. And what we envision is this ability to use WIT to describe host and guest interfaces. So this WIT would then generate out the bindings for the host and guest sides. So you could describe the interface that you want for this virtualization layer. And then you could implement the other side on the host and give yourself a very secure, stringent, fuzzed implementation on the host side, on the trusted side, and then expose that to the guest in a fairly fluent manner. That is not actually using WebAssembly components, but in fact, actually just more collateral from the WebAssembly ecosystem, which leads to we think, a pretty cool developer experience for building these kind of sandboxes. Ralph, do you want to show that demo?
I think we should.
Well,
Okay.
question. So you're going for a CNCF sandbox. How do you think it actually fits with Kubernetes and the CNCF ecosystem? Is it more like you are going to use like a runtime class or something to run Hyperlight, or have you thought about that, or not yet?
That's a brilliant question, Ricardo. Yes, absolutely. There was actually a item on the roadmap there. Example, use Hyperlight. So there's two ways that I could see this being used. Well, actually, there's probably many more, but two that pop up just right now. And one is you could run a native container and mount in the dev KVM or whatever your hypervisor device is, and then build and then use Hyperlight within your application in that container. And that would allow you to use virtualization to securely run untrusted code.
So it's in terms of security, right? So like, okay, got it.
Yeah, that's one way. Another way would be, yes, start to introduce, like, say, a runtime class. We see this being really useful in a scenario where, say, you want to run isolated functions, and you need to separate tenants from each other, and we could definitely look at doing that as a runtime class. The trick is we want to make sure we need to work with the community to figure out, like, what are the features that you want in that runtime. Like, how much do you need? Could you use WASI? Would WebAssembly work for that? And this can also, I think, help lead to how do we actually look at multi-tenancy in clusters? Because right now you look at, like, say, Kata or some other container virtualization isolation, but it's kind of heavy. This is a much lighter instance, so it gives you another tool in the toolbox to apply for security and secure isolation.
Makes sense. Yeah. I think it fits into confidential containers or like confidential computing, like end-to-end computing or trusted computing across the board.
Yeah, we have not looked at making these execute in trusted enclaves, but that's definitely something that's on the radar. we first, or I don't know exactly when that'll land, but that's definitely something that's come up several times. Is we want to have clean rooms. Yeah.
Awesome.
And
Thank you.
I'll just jump in and add a little bit. Think of also not just application workloads as normally conceived, but say, for example, any number of sidecars that get deployed, and you want the sidecar activity to be isolated even from the other containers in the pod, for example. This is one way you could do that. So if you think about things like network filters for something like Istio or Envoy, things like that, there are other areas, environments, those things need to be isolated, especially if you're going to chain network filters and they come from different locations. You may actually want them to run in an isolated fashion. So it also has potential to enable a stronger security stance for what I would normally call Kubernetes gearing. Also things like policy enforcement mechanisms, scanners, scanning processes inside Kubernetes, things that are getting more and more coming from the secure supply chain sort of epic that we're going through, to have a process do work inside a hardware protected memory space and then return safely at scale in a cluster can be applied in a lot of these areas that aren't strictly speaking a container workload. Stephen, you got your hand up.
Yeah, sorry, maybe just one question, then we can do the demo. Like, plugging into Kubernetes, for example, kind of like as a containerd shim or something, kind of loses the benefit a lot of times of the WASM interface, right? The fast start, all that kind of thing. Do you see this fitting in somewhere else and like the runtime level at that, for launching general runtime type things, workloads in that manner?
I think if we look at the sandboxing API and we start to have more of a sandboxed agent as opposed to a new instance every single time a pod starts, then I think we're on the right path. And we've been closely looking at that and working on the sandbox API at this point to try to kind of fix that problem with run WASI, is what I think you're referencing.
Right.
And then carry that over to Hyperlight, and how do we then use Hyperlight agent like daemon, perhaps?
Yep. Okay. Yeah, exactly. Okay, I'll let you do demo. Thanks.
All right.
Thanks, Stephen.
I'll do, make sure everybody can see it. Can you see the demo there?
Looks good.
Yeah.
Okay. So I do want to say that if you can see this as well, this is just VS Code. I'm going to tear this down. This is a demo that Dan did. It is the demo that is demonstrated in a little video clip. Dan has written a blog post that will come out sometime next week. And as soon as we got that link, we'll send it along. But you're getting a preview of that. It's pretty straightforward. We're just going to go ahead and get the host up and running. This is a Rust function, and it does a couple of things. There's little shadows behind me. There's various remodeling things going on in the environment. But what we've done is we created 10 sandboxes. This is a little web host. And so we can go over here and let's see, I need to get this out of the way. So I'm going to put it over there. There we go. I trust that the font is reasonable. So I can do if you're familiar with that, load tester. And we can go ahead and hit Hyperlight. Whoops. Hyperlight. Hello world. And we can do a cold endpoint, and that creates one new virtual process or protected VM space per request. And so we're throwing, hey, throws 200 responses over a single connection. And you can see at cold, we're doing like a hundredth of a second or a little bit more, almost 200ths of a second. So that's new. And this is on a machine that is my laptop that's a few years old. So it's like 16 gigs, 12 cores, whatever it might be. This is not an especially large machine. So if I move from cold to a pooling endpoint, for this, the pool has 10 VMs already in it. As we add load, if it goes to the pool, can't find a VM, it's going to create a new one and just execute per request. So every request is isolated in its own VM, and then the VM is recycled and added to the pool instead of creating cold. So if I do that with Hey, we probably popped out a few VMs now, and we've dropped down to 4 milliseconds, 4.3 milliseconds. So a very simple kind of what you might call a naive pooling algorithm here really changes the way things run. And yet you're still getting a brand new VM, brand new in the sense that the memory is completely reset and it is reloaded with the current request parameters. But now if we really hit it, I'm going to drop in, say, 5,000 requests instead of 200, and let's throw 5 connections in there for fun. If we really hit it, and this will take just a second to go, and the first time, of course, we're creating a bunch of, usually the histogram shows down here a few VMs being created, but we've now dropped down to the fastest one being 1 millisecond. We're averaging 6 milliseconds per request. I am, of course, serving Zoom over this machine and the whole deal. So if we do this again, it gets a little faster, and we're going to do it one more time, just fun. And you can see now that we're down to 1 millisecond here. If we dork around with the parameters a bit, you can really see things speed up. Connections across VM, this is in WSL versus Windows, so connections in VMs also do it, and we've just dropped to 1 millisecond. The average has gone up, the request per second, and so forth. In the demo that we dropped the link into, and if I'm not serving Zoom and also have Teams and a million other things running on it, on this very average machine, you can drop fastest one down to about 500 microseconds and average about 900 microseconds, which is actually what Rita showed in the demo. So that gives you an idea. In fact, there's a call here, Hyperlight, which I think is VM count. Whoops, I didn't want to do that. I wanted to do curl. Beep, curl. Yeah, so right here, we actually have created 44 VMs, and each VM is less than a megabyte. So even at that heavy load, when we're maxed out at 44 VMs, the memory load went up about 60 to 70 megabytes in RAM. That's it. So the density here is dramatically increased. The actual workload is very, very small, even though you're using full enterprise-grade hardware protection on that function per request, which is really quite something. The neat thing about this is that you could end up using this solution in other places. I'll go ahead and stop sharing. But you can use this solution in other places like small hardware gateways. You can run your networking services in small gateways on the edge, or any edge really, or in smart houses, smart buildings, whatever. And the processes that you're running there could be hardware protected. And that's really, really cool, right? That's not something that we normally think we can do, you know? So there you go. There's the demo. Any questions? I think Dan's here. I can answer questions about the demo, but they'd be lies. Dan would tell the truth. Yep. Oh, one other question. So when we were talking in the application, Dims had said something about asking about like some of the hardware, sort of the project dependencies, and he'd asked about verification. And one of the dependencies we listed was flat buffers, because we use those for speed over gRPC, for example. That's just an open source dependency. We have no responsibility for it per se. I don't know if other people had specific questions about that, but I want to make sure that we responded to any other questions that are along those lines.
AI related question. Can you run GPU workloads on top of it, or does it support GPUs?
We have done some proof of concepts. We do not have anything that is stable enough that we would like to endorse. We are working down that path.
Yeah. So I dropped something in the notes about a POSIX roadmap, thing. Realistically, POSIX is sort of a shorthand for how do we project devices that code can use in an easy way. We're not really thinking at the moment that we're talking about a full, complete POSIX spec API. What we're really talking about is, hey, does your code that expects files to be there, can it use the POSIX APIs to get them? Does it, networking, things like that? Well, guess what? One of those other devices, there's files, there's networking, and the other one is GPUs. So the answer is, it's on the roadmap somewhere. Yeah. We have used Hyperlight for a public demo of AI, but we use CPU processing there. We did not outsource like a computation to GPUs. So I'll drop that link in here, but it's not GPU. It's actually just a Microsoft person doing a demo with Hyperlight as part of the infrastructure. Yes, it's in line. Like we can see it over there. Over there. Where's the camera? We can see it over there. There's a bunch of geekery involved with that kind of stuff that gets really fun to talk about, but I don't want to waste the time here. The short version is GPUs don't hardware partition the way CPUs do.
Thank you.
Thanks for your time. Appreciate it. We'll be glad to come back if people want to dig in some way.
Yeah. Taylor, do you have a question?
I don't know if we wanted to wrap before we continue to other discussion. I just want to make sure I know some people said they'd be willing to stay, but I didn't want to force people into it. So I can come back after. It just was pre-raising, warming it up, as it were. No cold VMs here.
Sounds good.
Certainly. Thanks everyone for coming. We are at time. If you need to run, if folks want to hang out, feel free. Otherwise, thank you very much for all our presenters today, to Podman Container Tools and to Hyperlight. Thank you very much. This sandbox is open, in progress. Container Tools was in last month. You guys are on the list for Hyperlight. So we can provide some feedback as well to the TOC after today. Anyone who has to go, please do. Otherwise, we can hang out if you'd like as well. So thank you.
I can stay. David has another meeting. I can stay if there are more questions about this. Dan, you could go too.
Thank you so much, Ralph. Really appreciate it, everyone. Have a great day.
Yeah, I was just going to call out something Ralph was bringing up earlier that I think is just important in the context here of, just so people know, because the whole point of these is to be informational and show people what they're intended for and what their growth could be. Just something we toyed around with. We have no official plans yet, but something we've toyed around with, obviously, because, Ralph and all the people at Microsoft are friends. We've been collaborating with them in the WASM space for a while. Is that one of the big things that I see here from this is that, for example, David was talking about how WASM has like specific things it can expose that could be dangerous. The approach WASM Cloud takes is actually pretty much everything is, for all intents and purposes, a plugin. All of these capabilities that you can provide, such as file systems and whatnot. And something like Hyperlight lets us run those in more secure environments and then still provide the things back to the WebAssembly sandbox that's running. It's still WASM time in WASM Cloud. And so that's one of those other like future use cases here, is that all of those different styles of things can then be run inside of something like Hyperlight as an additional layer of protection for specific things, especially because it gives you all the knobs on the other side to do the hardware control access and saying, no, like you're granted access to these things, or hooking in, CNI or any of those kind of things on the other side of it, while still making it easy to just run it. So when somebody runs a plugin, they still have all the stuff they'd expect, but that's been restricted down. And so it gives us a good place because we in the project we've tried to make sure our trust boundary is always anything in the host is 100% like in the sandbox. There's very few extra dependencies in there. We don't embed servers or clients or anything like that. But then we can keep those external using these external things and run them in there. And so that's one of those future use cases. We haven't done anything with them yet, but I think it's an important context to see, like, from the WASM side, some of the interest that's coming from it, because you get the additional layer of isolation that David mentioned when I first asked the question, and you get things like what we're wanting to do with it in the future.
Yeah, that's actually a great way of explaining one of the key uses. I mean, I can also say, I mean, David sort of described it, but like, for example, at Azure, we just can't run in the fabric. We can't run, untrusted code, and also we can't run like sandboxing technology like WebAssembly, or even like, for example, a Java, like .NET doesn't even do a sandbox technology anymore. We don't make guarantees, for example, and you can't run services natively in Azure with that. So everything has to be virtually protected. And so for us, when we wanted to run WebAssembly, we needed to find a way to be able to enable the fastest WebAssembly functions we could do, where the process could match the speed but give us the physical security that hardware protected virtual partitions give us. And that's why we built Hyperlight. And it turns out that, like Taylor's description, is just a way that a trusted host, for example, can shell out other code and protect it in a hardware way at the speed that it was developed for, which is WebAssembly. But ironically, the lack of hardware inside and the lack of devices, operating system APIs like POSIX or anything like else means that it's just not going to be a generalized tool right away. So it should be clear that this is not like a Docker thing where you're gonna, like, every application will just go, oh, hey, pull in a micro guest or whatever. There will be, some developer experience improvement there, but fundamentally the environment is embedded code. It's like writing for a chip, right? Like there's nothing in there. So you have to bring everything in there that's necessary to run, which a good engineer can do, but an application engineer at speed trying to produce, things for their company probably doesn't have the time to learn how to do that. And so there is a learning curve for the level of protection and speed you're getting here. And so it would be up to something like Wasm Cloud, for example, to sit down and go, okay, no, we can make use of this, and we'll build exactly what we want for Wasm Cloud to work there. And if it were things like WebAssembly components, and the component ecosystem would still work fine, right? So that part wouldn't change, but their integration with whatever they were, like a plugin, for example, would be something that Wasm Cloud could do and provide to its users, but they would never see it. It would be at the systems level, really, the application platform level. So that's worth calling out. I think people we can make the dev UX experience much, much easier, and we have ideas about how to do that. And we could even put micro guests in OCI artifacts and pull them in, right? Like, that's possible. But at the current moment, nobody should walk up to Hyperlight going, oh, anything runs. That's not true. It's still a little, you got to do a little bit of work. So I can show Dan's code, for example, the Rust code if you want, but it's going to be out in the blog and you'll be able to see it.
So you had said that this has been used inside Azure for some time.
Yes.
Is that all on bare metal then?
No, it's used in the areas it's used. So, for example, Hyperlight itself is the core infrastructure for Azure Front Door Edge Actions, which is the CDN serverless solution.
Okay.
That's been announced, so it's okay to talk about, and
Sure.
like I don't have to worry about it anymore. But it's also being built into 2 other services as we speak that haven't announced yet. And we will enable it in AKS as we discussed. But the real thing is we haven't exactly decided precisely how to enable it in an efficient way. And in an AKS-like situation, the real question is, for people who want to use Kubernetes, that's going to be something that could be installed anywhere. It wouldn't be an AKS thing. It would be the normal kind of thing. It would be a runtime class, or as David says, something like where, hey, you can actually, the container app might actually be a scheduler.
Yeah.
Right.
Yeah.
Rather than just having, one thing being there in the kind of standard way we think of a runtime class or a container runtime instance, for example. But there are also other things too. We've chatted quite extensively with the Envoy maintainers and the Istio maintainers, and have done an internal POC. In fact, there's a talk proposed. I think it's for rejects. I'm not sure, but it might be somewhere else because my brain is basically broken. But in any case, there is a talk about that will be out soon in the open source. I want to say it's 6 p.m. here in Italy, so I'm getting a little punch drunk. Forgive me. But basically, I want to say in the open source CNCF concert series, not the conference series, but the concert series, which is essentially the demo. It's a talk about building Hyperlight so that it supports Envoy network filters. And so each network filter can run isolated inside your Kubernetes cluster from the other network filters that are in the pipeline. That is another, for example, Taylor's case is a perfect use case, right? For example, that's another one, an obvious one, right? It would be really great if the gearing in Kubernetes, especially pipeline things like network filters or Rego evaluation or whatever it might be, including AI workloads, because those are coming, where there's going to be a scheduler where the AI figures out exactly what it wants to do with your cluster at that time. Things like that probably need blast radius walls. And this is the kind of thing that's designed to enable any of those processes to kind of leverage the 30 to 40 year hardware blast radius wall that that VMs provide, but do it at a speed that is, fast enough that it makes Kubernetes look agile. Right. That's the idea.
And it's still fast enough in that nested KVM case.
Yes.
Because there's essentially no overhead, right?
Yeah, it's very little overhead. And the interesting thing is that, so the work that we're trying to do with the POSIX implementation is actually direct hardware routing, so that you can actually not load VirtIO underneath the POSIX call, but hit the virtual device directly, no kernel pass through, so no transition at all. Either inside the micro guest, or you could choose to route it to the host application, and that would be an option. But in the guest, even in the nested virtual space, the slowdown is extremely minimal. Like it, the truth is that once we built it, sure, Danielle, cheers. The surprise, I think, is that once we built it and we saw, like, for example, when we were really testing it out early on, we could create just a functional, hardware protected process in like 60 microseconds. 6.0, not 600. The version we have now has a lot more protection involved, a lot more kind of rigmarole to get through. And we're still, you can get there at 600 microseconds, which is, crazy fast for what we think of as virtual machines. And it really, what it showed us was how much work a CPU does just to handle an operating system and the virtual driver, the device drivers underneath the operating system between POSIX and the actual devices themselves as they're projected into the partition. It's amazing. You're essentially ripping out 40 years of work that we take for granted every day in a container, for example. Hey, there's a kernel. It all works, and you rip that stuff out and all of a sudden things just scream in modern hardware, even at the nested virtualization level. So, for example, the demo I showed, the machine is not a particularly big machine. And I did not reach the 900 microsecond average that Rita reached on her machine when she did the demo on Keynote. Well, in this particular case, I got close, but I didn't get there. And in this particular case, I'm running Zoom, I got Teams going, I've got video streams, the whole ball of wax is going on right now. And then this application is hosted inside WSL. And VS Code is connected not to that WSL VM, but a different WSL VM. And so what we're doing at that speed that you saw, which was like we were averaging about a millisecond, which for me is a little slow, we're actually doing network bridge calls between VMs through the hypervisor manager. So even there, you're actually working with nested VMs and bridge calls, bridge networking. And it's still really, really fast. So the core technology is great. The thing that'll be hard, like the harder part of the work, is the next year, where we got to figure out exactly how can we have POSIX devices there without an actual kernel. And that we have to keep the cold start speed to 1 to 2 milliseconds. Well, it's going to float higher once we put more code in there. That is obvious. But half of the performance, I'm swagging at half, but I'm just waving my hand that a huge portion of the performance that we usually attach to the concept of cold start is actually rightfully attached in production, is rightfully attached to pooling and connection and instance management. So for example, although I can create a new VM and execute this function very, very fast, it's really not, that's not the brilliant thing. It's the fact that they're so small that when you pool them, you don't consume any resources relative to other regular programs that are running on this computer right now. That's the surprising part. So if you pool only 44 VMs, which is 60 megs of RAM, 70 megs of RAM, you can go and drop the performance through the floor. That's the part that's funky. If I add, let's say, just flagging, if I add 10 milliseconds of cold start, it really doesn't impact that larger performance dynamic as much as I originally thought when we were starting this. That's the funny part. So the nested virtualization, not a problem. It's not a big hit.
Not a big deal. That's really interesting.
Yeah, it is. Anyway.
Yeah, thank you so much for going through all that.
Yeah, sure. And we're happy to come back later if people want to dig in. It's fine. And the meetings are open. I don't know if we dropped in the meetings, but there's we got a bi-weekly meeting, and we had asked the CNCF, we had asked Daniel Crook. I said, listen, can we create a Slack before we get in the sandbox? And Daniel said, that's a gray area. So we got our own Slack, but then we'll move that over to the CNCF. If all things go well. Right?
If you haven't put the meeting link somewhere, that would be cool.
Sure. Hang on 1 second so I can do it. Here because once Zoom goes away, man.
Yeah, you're totally right about that.
Goes away, goes away.
Yeah, I don't see it in the sandbox application, but that'd be
No,
cool.
because
As a
it happened this week. I'll put it in.
Yep, cool.
Absolutely.
Cool. That'd be good to
Oh, actually, I'll put it in there.
yeah. That's a good idea.
And because otherwise I'm gonna run around different Slack channels and Teams channels and things like this, and I won't find it exactly where it's supposed to be.
Yep.
But I will drop all that into the issue.
That's the best option. Anything else you wanted to share that you shared today, feel free to put in there as well.
Okay.
I tried to capture all the links in the runtime meeting notes here.
That's very kind of you.
Yeah. Sounds great.
All right. Cheers.
Thanks so much. Take care.
Thank you. Bye-bye.